Okay, sample 14. Look what we've got here. We've got the nastiest looking rational expressions here and here that we can find. And we're actually going to put these guys together to give me f of g of x. Oh my goodness. Okay, so how do we do this? Well, remember, we're taking f of g of x. So g of x, which is this right here, has to go inside the f of x. Well, I hope you got lots of paper for this one because this is going to be interesting. Tell me what the original f of x looked like. Well, there it is. So it's blank plus 3 over 4 minus blank. And those blanks are going to be replaced, of course, here and here. Woo, baby. Look at this. So in this first one here, I'm going to put in my 5 minus x over x minus 4. And in this one, I'm going to put in my 5 minus x over x minus 4. These are going to be quite interesting to do. So you know what I'm going to do? Let's break this off into two sections. I'm going to do this as the numerator first, follow it up by the denominator, and then I'm just going to put this all together, okay? So let's start with this one. So this one starts off with 5 minus x over x minus 4 plus 3. Now, you know and I know from the rational units you did in Math 20, and I'm sorry I keep bringing that up, but it's true. You should know how to do this by now. Multiply this common denominator by x minus 4, right? Okay, so this gives you on top 5 minus x, distribute, plus 3x minus 12. And of course, there's our common denominator. Oh, that's not so bad. Okay, combine like terms. There's a minus x and 3x. That's going to give you 2x. And I've got a positive 5 and a minus 12 to give us minus 7 all over the common denominator of x minus 4. So at this point right here, I'm going to stop because I haven't done any canceling or anything like that yet. And what I'm really interested in is what the restrictions are. So don't forget, you have a denominator here. X minus 4 cannot equal to 0. So of course, x cannot equal to positive 4. There's one of your restrictions. Now, let's see if we got another restriction coming up here. Time to do this denominator. Well, the denominator then works out here. This is 4 minus 5 minus x over x minus 4. Okay, so again, over 1. That means I'm going to multiply both of these guys out by x minus 4, x minus 4. Got it? Okay, so this gives us, distribute, 4x minus 16. Now, don't forget, here's where a lot of people forget to put brackets around that because that negative is distributed to every member of that numerator. So this becomes minus 5 plus x all over common denominator x minus 4. And look at that. We've already taken care of this non-permissible value right here. Okay, combine. 4x and x gives me 5x. Minus 16 and minus 5 gives me minus 21 over x minus 4. Now look how pretty I line this up, because guess what? There's our numerator, there's our denominator, and we're just going to divide these two things. Huh, well, how do I do that? Okay, wait a second. I'm going to rewrite them here, okay? We know that this is 2x minus 7 over x minus 4, right? This is going to have to be divided by 5x minus 21 over x minus 4, right? So there's our non-permissible values taken care of right there. But we do have another non-permissible value because guess what? In order to do this right, we have to flip it. This becomes 2x minus 7, x minus 4, just like grade 7 fractions. We flip it and multiply. There's our x minus 4 here. There's our 5x minus 21, which makes that a denominator now, right? So since that's a denominator here, 5x minus 21 cannot equal to 0 either. Bring the 21 over, right? So that means x cannot equal to 21 over 5. There's your other non-permissible value. Now, clean this up. Cancel the x minus 4s, leaving you with a 2x minus 7 over 5x minus 21 with non-permissible values. X cannot equal to 4 and 21 over 5. Wow, what a cool question, and what a great way to finish off this unit.